Okay, we now have HC and we have ZN, which is the azimuth, which is the angle of it. This isn't enough yet, though, to actually find our LOP, because all we've done is we've set up this angle and this line here based off of our starting information, but we have to compare that to our HO, our observed height. The accurate height we're actually using our sextant to calculate. We have HS that was given to us in the problem, the height we measured off of the sextant, but that's not perfectly accurate enough. We have to apply a couple corrections to get HS to HO so we can actually do this computation here, which will give us our line of position. So that's what we're going to work on now. We'll come to our problem. First November. Do the 18th of August first. And now we're going to work on the same page so we keep all of our information together, but this actually has nothing to do with any of this, because all of this work was ultimately to find HC and ZN. All of our next work is based off of the stuff we physically measured, the sextant height itself. I told you there's an issue with making it really like crowded and hard to read here. So we're going to write it off to the side. I'm going to write the steps in advance here so you can see. We're going to start with HS, IE, dip, gives us HA, main, and HO. So what this all is HS is our sextant height. That's the one we actually measured off to the sextant. And you can see we've got written at the top of the problem here, we had 65 degrees, 06.3 minutes. And a good thing to check is your HS and your HC should be close. So whenever you find HC out of the book, you should automatically go back and look at your HS and see how similar they are. And if they're like within a degree, you're probably correct. You probably are doing something right. If they're 30 degrees separate from one another, then you've definitely messed up somewhere. And you can see we've got 64.56 and 65.06. Close enough. They're probably good. So HS is sextant height. IE is our index error. Index error for us is 0.6 minutes off. Index error is the physical error in the sextant. Sometimes they're just not printed correctly. Sometimes there's little mechanical problems in it. There are techniques you can use to measure your index error when you're physically getting a sextant, and you should do this as often as possible. Every time you take your sextant out, you should measure its index error. Off just means that whatever it measures, it measured 0.6 minutes less than what the actual height is. That's why it's off. It's 0.6 minutes off of the arc. If it said on, it would be 0.6 minutes more angle than what the body actually measures. So 0.6 minutes on the arc. So we have that written there. Dip is our height of eye correction. So this is going to be two things, and normally we write our height of eye in parentheses. So our height of eye is 61 feet. We're going to write what that is equivalent to in dip. So remember how high above the surface of the earth you are. I believe it was, see how high you are above the surface of the earth impacts how far off the into the horizon you can see, and changes what this total angle is. So we're going to use our dip correction to get that back down to a perfect 90-degree difference between the horizon and the zenith. So that's why we need dip. Then HA is our applied altitude. That's just that is just after we've done these two corrections, what we get the height of the body to be. So you could think of HA as if you took HS and you corrected for all of the error that was caused by you physically measuring the body, both in the error of your sextant and how high you were above the water. So the things you did that messed up the angle, that's what applied altitude is. That's after you've corrected to get it. The main body correction is the adjustment from if you measure the lower limb of the sun or the upper limb of the sun, adjusting it to the center, because all of the calculations in the Nautical Almanac are based off of the exact center of the sun, not off of the bottom or the top. So the main body correction adjusts from the lower limb or the upper limb into the center. And then once you've applied that, you get HO, which is the true height of the sun above the celestial horizon, accurate, much more accurate than what you measure off of the sextant. So we're going to go through the problem here. The first thing we got to do is we just have to look up what a dip of 65 feet is equivalent to. So the way we do that, all of these measurements are in the Nautical Almanac on the first page. I think I talked to you about this before already. They're all right here. You can see the sun stuff. This is all main body corrections. This is stars and planets, so we can ignore this. And then this is dip corrections. So this is what we're going to work with first. Our dip is 65 feet. So we come to the table and we work our way down. You can see we've got height of eye in meters on this column. This is meters, and then this is feet, and then the correction is in between the two, so you can just pick which is equivalent. Then here is like for larger values, but we don't normally get that high. So you follow the feet down until you get the closest thing to 65 feet. So you can see here we've got 63 feet, 63.8 feet, and 65.4 feet. So we fall somewhere in between the two. So we're going to pick the dip value that is in between the two. If we were 44 feet or 45 feet, we'd be between 44.2 and 45.5. So we'd pick the dip correction that's in between the two. So we're in between 63.8 and 65.4. We get minus 7.8. This is all in minutes. This is always in minutes, and it says at the top here minutes. So minus 7.8. So we write off to the side here, 65 is equal to negative 7.8 minutes. Now that we've got that ready, we can apply these two corrections to get our HA. So remember, for index error, you just do the opposite of what it says. If it says off, you add. If it says on, you subtract, because off means it's less than what it should be. On means it's more than what it should be. So in this case, off, we add. And both of these corrections are in minutes, so we kind of don't even need to worry about the degrees here. We just worry about 6.3 minutes. So we do 6.3 plus 0.6 gets us 6.9 minus 7.8 minutes from the dip correction. Minus 7.8 gets us negative 0.9, which just means we carried back over to 64 degrees. So we plus 60 to carry the 1, 59.1. So our HA is 64 degrees, 59.1 minutes. Good. Now our main body correction is based off of what our HA value is. So we come back to this page. You can see the main body corrections are based off of apparent altitudes. So we're going to pick whichever one is relevant to our value of 64 or 59. But first we've got to pick a section. You can see at the top here, this is for October to March, and this is for April to September. Well, we're in August. This question takes place, still can't see. This question takes place in August. So we're going to use April to September, and we use the sun's lower limb as it explained in the question. So you always have to refer back to the question to get all your information. So we're going to follow the lower limb column instead of the upper limb column. And we go down. We're looking for an applied altitude of 64.59. Closest we get 61.51 and 67.17. So we pick the value that's out that you couldn't even see, 61.51 and 67.17. The value between them is 15.5 positive, so we use plus 15.5. Plus 15.5 minutes. Had we used the upper limb, we would have used minus 16.3. And all this means is At this time of year, if you'd measured the lower limb of the sun at 64:59, then the center of the sun was 15.5 minutes higher than that. Had you used the upper limb, you would have had to go 16.6 minutes lower. So then we add these 15.9 or 15.5. We get plus 59.1. We get 74.6, which we subtract 60 from, and we're back to 65 degrees with now an additional 14.6 minutes. So our HO for this problem is 65, 14.6. We're going to go over to the 4th of June, and we're going to do the same process again. So we've got HS, IE, dip, HA, main, HO. Okay, our HS, the problem says, is 25 degrees, 57.8 minutes. First things first, let's see how close this is to our corrected HC. We have a corrected HC, 25 degrees, 22.9. So we're about 30 minutes away. That's on the large side of what it should be, so we'll see. But it's still probably good. Plus, we've got to correct more. Index error is 2.1 minutes off. Our dip is 30, our height of eye is 39 feet, and that's what we're going to use to find our dip. So step one, we come to the dip section. What did we say, 39 feet? Yeah, 39 feet. So we look down the dip column, height of eye in feet, 29, 38, 40. So 39 is between these two, negative 6.1. So we get minus 6.1 minutes. So now we can apply these two corrections. So 57.8, 2.1 off, so we add 2.1, gets us 59.9, minus 6.1, gets us 53.8 minutes, 25 degrees. Okay, now we look for our main body correction. So remember, first we need the time of year, lower upper limb, and our HA. So time of year is 4th of June, and we're using the lower limb. So we've got October to March and April to September, so we're on this side again. And then we're using the lower limb. So we come down, what did we say, 25, 53.8. So we come down, here's 24.50 and here's 26.0. So we use between the two, gets us plus 14 minutes. Plus 14.0. Okay. Now we add that correction to our HA. So we have 53.8 plus 14, 67 minus 60. We have 26 degrees, 07.8 minutes, which is our HC we calculate is 25 degrees, 22.9. So there's a pretty large gap between the two, which whenever I see that makes me kind of nervous. However, it's important to remember that this is all you remember HC is based off of your assumed position, your assumed latitude and assumed longitude, whereas HO is your true actual position because it's the one you actually measured. So if the two of these are different by a lot, you could have messed up, or it's possible that your assumed position is just really far, or pretty far away from your actual position, which would cause this difference to be pretty high or relatively high. If it's ever more than a degree, that's a problem and you probably did something wrong. But this is only like 40 minutes apart from one another, which is suspicious, but not a guarantee that you're wrong. We're going to go to the last one. We're going to do HS, IE, dip, HA, main, HO. So our sextant height for the 21st of November problem is 44 degrees, 29.2 minutes. Our index error is 1 minute on. Our dip is, our height of eye is 61 feet. Okay. Step 1, find our dip correction. Remember, this is just the very front page of the Nautical Almanac besides the accreditations and table of contents. So we come down to 61 feet, which is the same as, or as close to the same we used before, between 60 and 62. So we get negative 7.6. So minus 7.6 minutes. All right, now we do our corrections. Our index error is on this time, it's not off, so we subtract it. Remember, off, add, on, subtract. So 29.2 minus 1 minus 7.6, 20.6. So we got 44 degrees, 20.6 minutes. Now we come to our main body correction. Time of year is 21st of November. And we get, I actually forgot to write down whether it was the lower or the upper limb. I assure you it was the lower limb. People never measure the upper limb. I mean, make sure you check. Whenever you do your problem, check so that you're not wrong, but I'm fairly confident this was an upper limb problem. So 21st of November is in this column, October to March, and we come down to, what is it, 44 degrees, 20 minutes? So, further down, 43, 47. So we've got 44 between the two. If it was the lower limb, it'd be plus 15.3. If it's the upper limb, it's minus 17. I'm going to assume it's the lower limb. Plus 15.3 minutes. So we add that to 20.6, and we get 44 degrees, 35.9 minutes. And if you look, our HC is 44 degrees, 29.3 minutes, so they're very close. So that's a pretty good indicator that you're pretty accurate with your information. So it doesn't matter whether you do all of this to find your HC and your ZN first, or if you do this small bit to find HO first, you're working in parallel. It's just like in TNAV where you're working for your luminous range and your geographic range. It doesn't matter which one you pick to do first, as long as you get both in the end because you're comparing the two.